Hello, welcome back to week 2. I'm Yash Adavalli. Today we'll be talking about map design and vector data display. So under map design we'll talk about thematic mapping, which is also called CHOROPLETH maps, and then we'll talk about how to use color schemes and stuff like that. And as part 2 we'll talk about vector data display, which is essentially displaying points, lines and polygons as part of your GIS interface. And then we'll talk about how to use GIS queries, and we'll also talk about map layering and how to turn layers on and off based on scale thresholds, and then we'll talk about hyperlinks and map tips. So getting started, tutorial 1, map design. So CHOROPLETH maps, or what we call as thematic maps, are usually color-coded polygon maps. So if you can have anything like a polygon, it could be since track, since block group, or any other, it could be parcels. So when you use monochromatic scales or saturated colors to actually color these polygons, what you get is CHOROPLETH maps. So usually we use these maps to represent some kind of numeric value, like if you are talking about census geographies, we're talking about maybe something like total population, or number of housing units, or percentage of vacancies, or population densities, or income, median incomes. It could be anything. So this is a good example. Like this map is for the entire US counties, a map of US counties, showing percentage of vacant housing units by county. So this is an excellent example of a thematic map or a CHOROPLETH map. So now you get the idea. It's fairly simple. These are polygon. This is vector data again. Polygons, where you are using a numeric value, which is housing vacancy or total vacant units, percentage of total vacant units, and then you're trying to display them using dichromatic tones, which in this case, which is yellow or light cream color to a blue. So there you have it, an example of a thematic map. So the main step in creating a thematic map is classifying data, so which is nothing but placing data into different groups that have similar characteristic value. So these we call as breakpoints. So what breakpoints mean are they break up the total attribute. You take, like, I don't know how many counties, maybe 1600 counties in US, something like that. You take all the counties and you sort of, like, break all the counties into these 5 different groups, which actually into these 5 different intervals, and you use some kind of like a mathematic progression or a formula instead of actually picking some kind of like random numbers. So there are inbuilt techniques to actually do this within GIS, which we'll talk about in detail, like natural breaks or equal intervals or quantile definition or geometric interval or standard deviations. There are different ways of classifying data, but what you need to understand is that you need to classify data in order to place this vast amount of data into different groups. So in this point, 9.85 is a breaking point, 16.79% is a breaking point. Yeah, so you get the idea. Like, so you use these breaking points to create these classifications. So let's talk about natural break classifications, which is actually created by, it's also called Jung's natural breaks classifications. So what this does is this is a it breaks the best. So natural breaks classifications, what they do is this is sort of like the best classification system there is within GIS. It naturally breaks all the data into such groups that it naturally maximizes the differences between the classes. So usually it does it in a way that there are like large jumps in values between these classes, and these classes are usually uneven because So this is usually done based on a subjective decision, and it is usually the best choice for combining similar values. We'll talk about normal, like the different types of data again, but this class range is specific, are very specific to individual data sets. So it is very difficult to compare like the map that student A created versus student B, because they might not have used the same classification system. So again, unless they are put in the same, they're using the same break values, it's extremely difficult to compare two different maps. Classifications, quantiles is a what it does is it takes all the data and places the same number of data values. So let's say you have 1600 counties and you place the 1600 counties into 4 different groups. So each group will have 400 counties in them. So the data is classified in such a way. So it's called quantiles, and it is an attractive method because it produces very distinct maps, distinct map patterns. So analysts use this because they provide information about the shape of this distribution. For example, like what we talked about, we have 100 values, the first one, and we have 4 classifications, let's say 4 groups. So each group will have 25%, 25 values within them. So equal intervals, what this classification system does is it divides a set of attribute values into groups that contain equal range of values. So let's say we have 5 different values. A couple of them are values 2, 2, and you have 3, 3, and you have a 5 or something like that. And what you do is classify them into 2 different equal intervals at 0 to 3 to 3 to 6. So you are, by doing that, you are actually having the same equal interval between the 2 classifications, but you are ignoring that there is clustering within this data at 3s and 5s and and 2s. So again, so this is what you need to decide when you are doing classifications: is my data clustered? Is my data equally distributed? So you need to read the data and make sure you are using the best classification system possible. So one way to do would be to actually play around with this classification system, maybe look at a histogram of data and so on and so forth, to get the best classification system out of this. Again, that's where natural breaks classification system is better than this, because you can use that on clustered data to actually produce good looking maps in terms of identifying spatial patterns. And moving on, there is exponential scales, which is a popular method of increasing intervals based on a mathematical formula like 3n or 2n. Generally starts out with 0 as an additional class. So it depends on how your data is laid out, essentially, and then you can use increasing interval bits also for long tail distributions, where the data distributions deviate from a bell-shaped curve. So you can look at like a histogram and then see if it is like like whether it is skewed to the right or the left with a tail elongated, and then you can actually keep doubling the interval at the interval of each category and have interval bits of 5 to 10 and 20, 5, 10, 20 and 40 or something like that. Again, you have to examine the data to identify the best classification system. So let's look at an example. This is original map of US population by state in 2000, and this is like, let's use natural breaks, which is like sort of like a default method for classifying data with an ArcGIS system. So once you use that, you get a pretty good view of United States. We know California is one of the most populated state, and then you have some of the main states pop up like Texas and Florida and Illinois and Ohio and Michigan and so on, and New York. So this looks pretty good, but if we use the same data, if we use a different classification system like equal interval, it's not so good, because this map is not doing justice to the actual data. Now we are not seeing some of the states that are with the same intensity as we did before. Even though the data is not wrong, it's being classified using a different interval or different breakpoints, and too many values fall into the lower value classes. So what if we use a quantile scale showing increasing width, geometric scale? So this, I like this, because you are actually popping out a lot more top tier states with this classification, and you are also there is definitely a clear distinction between different states. You see some of these top north Midwest states and East Coast states pop up a little more, and this map actually does justice to how the things are on ground right now. What if we do like exponential scales with the power of 2? We get a different looking map. I'm not too sure if this is the best looking map. This could be. This is a pretty good map though. So again, it depends on what you're trying to show and what your data is telling you, and whether you are happy with the story you want to portray. So if you are a state of Texas, and you are going into a presentation saying, hey, look at our state, how good we are within the nation, you want to show this map. But if you are a state of Illinois, you don't want to show this map really, because you want to show this map and say, hey, look, we are in the big leagues, and we we are one of the top states in the United States, which they are again. So it really depends on who your audience are, what you're trying to do with the map, and what your data is telling you. At the same time, not try to skew the data too much. There is something called lying with maps. So you don't want to lie with maps. You just want to keep it real enough and tell the story you want to say at the same time using the data. So so that's creating working with different classification systems. So moving on, there is something called normalizing data, dividing a numeric attribute by another in order to minimize the differences between the values based on the size of the areas or number of features or so on and so forth. For example, dividing the number of vacant units by total units would give us sort of like a percentage of vacant units. That would be a much better measure than total number of units, because we'll see an example. Or something like dividing the population by area would yield population density, which would be a better measure to look at in few cases. So let's look at a non-normalized data example where you are actually showing the number of vacant housing units by state in 2000. And this actually says that there are way too many vacant units in New York City and California and Texas and Florida, and but in reality, if you do a percentage, that's not the case, because there are a lot more housing units. When you are just actually mapping total vacant housing units, of course they are popping up a little more because they are really big states with a lot of housing units or a lot of people in them. So when you actually normalize it by percentage, that becomes a much better value to look at, because that's a more representative ground reality. So again, non-normalized data, this is just like the total California population by county, which shows that there is a lot of population down south, and oddly enough, it's not actually showing a lot more data. The darker areas should be around the metropolis, which is not the case here. So if we normalize this data by density or by area, then we actually see the trend here, like the SFO, the San Diego, LA area, Los Angeles, these areas pop out a little more because this is by density, and there are a lot more people living in a lot less area, so there is higher density in these metro areas. Again, it depends, you want to see both maybe in some cases and see which one fits your description. So again, let's talk about colors a little bit. We've been talking about how to classify data and how to actually normalize data, but it's important to talk about colors because there are different things you want to do. I have seen a lot of maps, and some of the maps are honestly really not that good because the data would be fine, the classification system would be fine, and everything looks great, except that they use terrible colors to actually portray this information. So it's important to understand. I know you're not a designer, I know you don't care about, you may be a statistician or something, but one of the main reasons you use GIS is to actually show the create a good presentation. That's one of the key purposes of GIS, is spatially display data through good maps. So how do you create good maps? Is by good colors. So let's talk about colors. So hue is a basic color like RBG, like red, blue and green, and the value is the amount of white or black in the color. So when somebody talks about hue value or hue saturation, or saturation refers to a color scale that ranges from pure hue to gray or black, and value is amount of white or black in the color. So it's a little important. It's not absolutely critical, all this stuff, but I threw it in there because it could come handy at some point. So color wheel is extremely useful in choosing colors. It sort of provides like a guide. I use this a lot as a guide because when you use opposite colors to differentiate graphic features, you get a better looking map. So 3 or 4 colors equally spaced around a wheel are usually good, just like let's say blue, violet, red and orange are excellent colors, or yellow, green, blue and violet and red would be excellent choices for your class, for your showing to differentiate graphic features on your map. So using adjacent colors in cases of colors for harmony. So if you are showing like population density, income, median incomes or something, you want to show, you don't want to actually pick colors from opposite end of the spectrum on this color wheel. What you want to do is pick adjacent colors, because this is continuous data, so to speak. So these, like let's take incomes like 10 to 20,000 could be light blue green, and 20 to 40 could be blue, and then 40 to 80 could be blue violet, and so on and so forth, and more than 100,000 could be red or something, so that you see a gradual increase. So that's when you use adjacent colors for harmony. So light versus dark colors, usually light colors are associated with low values and dark colors are associated with higher values, and then for a human eye is drawn to darker colors more because of the way we are wired. So at the same time, it's important to have contrast, because the greater difference between the greater the difference in value between an object and its background, the greater the contrast. So we'll see some examples. So we need to understand monochromatic color scale, which is a series of colors of the same hue or same color, going from light to dark or light to black. This is commonly used for CHOROPLETH maps, and the darker color in the monochromatic map scale is used for the important graphic features. So we need to use more light shades of hue than dark shades in monochromatic scales, because the human eye can better differentiate among light shades than darker shades. You can play with this and know this for yourself, or you can actually follow simple techniques. So this is a good monochromatic map, and you can obviously see the values are too similar here. So a better map would be something like this, where you use a darker tone to actually identify the main features within the map. So in this map, you can't really identify the higher value features like 28% to 34%. So you need to pick your colors a little carefully, because it makes a huge difference to your audience. Dichromatic color scale is an exception to typical monochromatic scale used in most maps. The two monochromatic scales join together with a lower color value in the center, with the color value increasing towards both ends. So it sort of uses like a middle point, such as a 0. If you're talking about population growth, the negative values would be green, and the higher and the positive values would be maybe something like a red or something like that. So dichromatic map, you're going from symmetric breakpoints centered on 0 make it easy to interpret the map. So if white is 0, or 10 decrease to 10 increase, or like normal values, and then your blues would be decreasing values and reds would be increasing values, which would actually make the map very easy to read. So color tips. Colors have meaning, political and cultural. So cool colors are calming, and they appear smaller and sort of like look a little receded. So you might want to use them for like negative values. And warmer colors are a little more exciting. You want to use them for positive values. They usually overpower cool colors. Cool colors are usually like greens and blues, and the warm colors are obviously red, the reds and the yellows and stuff. So more tips: do not use all the colors of the color spectrum, because you don't want people to be confused about your map. So if you have relatively few points in point layer, use maybe size instead of color values to symbolize your numeric attribute, because if you use especially for points, if you are using different, the points are usually very small and it's hard to read them. So if you use colors, that might be a little tough to actually read. So maybe instead use sizes, which we'll talk about. So if you have many polygons to symbolize, it's better to use polygon centroid points with a color rather than polygon CHOROPLETH maps. Again, we'll talk about what's a centroid and how to actually create them and so on as we go on, but that's a good tip to know. So in this map, maybe we are showing property values or assessed values or something like that, or maybe this is census tract, too many polygons. So instead of doing that, if we show polygon centroids, that becomes a much easier map to read and identify patterns and so on. So again, a very good tip to have. So changing colors in ARCMAP. Choose color or more colors, and I'll actually show you in the walkthrough how to do this. You can pick any color you want, and you can pick from any of the schematics like HSV or RGB or CMYK, or you can actually pick from a more standard color color chooser that is built into ArcGIS. If that's not enough, you can go to the other color selectors. So there is more to, if you want to learn more about colors or GIS colors, you can go to colorbrewer2.org, and there are some really good books, especially designed maps. The source book for GIS users is really good, and the book I really love is the Designing Better Maps, a guide for GIS users. Is fantastic. I really like that book, and it actually that's a map. That's a book I usually go for reference if I have any questions about it. Like if I'm picking complicated color schemes and stuff. So let's pick it up after a little break on displaying vector data in GIS. So vector GIS display. So we know there are three primary types of vector data in GIS. One is points, which has x and y coordinates, and lines. It has a starting and an ending point. And there is a polygon where you have three or more lines formed together to form a closed area. We already talked about this, so we'll talk about how to actually display this information. Feature attribute tables, again we know, stores characteristics of vector features. Like in this particular table, you're talking about shape file, like a point shape file, where you have, looks like these are address points, where you have street number, street name, nature of some kind of like COD. I'm guessing this is some kind of a crime, and the address, which is a combination, and then we have drug impact and so on and so forth, and a 911 call date. So layers can be displayed using attribute data. So let's see how that's done. So displaying points, single symbols. These are like, you can see all the points, and you can see how they're being displayed, and you can see that these are all the points represent 911 calls. So there are a couple of ways of doing this maybe. So if we display the same data based on same features, different points, maybe points could be the type of crime, which could be burglaries or drugs. So when you do that, you get a lot more information than actually just displaying simple points. So displaying points, when you actually symbolize this point data, you can use industry specific symbology. In this case, we can use something called crime analysis symbology. Within that, ESRI has given us a lot of symbols like predetermined, pre-generate. It's already part of the package. You can actually use the symbols to create your own, use these symbols in your own map presentations or map documents. So good, especially this is good for large scale maps. Just briefly about scale. So this is actually small scale maps have larger areas, which means cities or states or countries of the world, and large scale maps have smaller areas or large amount of data. So small scale means smaller detail, large scale means larger detail, which means zoomed in. So large scale maps could be neighborhoods or street level or block level or something like that. So in this, for displaying points in a large scale map based on industry specific symbology could be extremely useful. As you can see, if you can categorize them by gun weapons, burglaries or muggings or narcotics, incidents by narcotics, it becomes extremely useful to actually see this map. So displaying points, for example, schools have their own symbology within ESRI, but it's not really useful in a small scale map which is actually smaller detail. You're looking at the entire Pittsburgh city, looks like, and these points, in this case, a large scale, a simple point like a red dot would be a much preferred, much easier option or much clearer option for displaying school data at the city level. So instead of actually using colors, it is extremely useful to use quantities by exaggerating them by sizes. So if you actually group them by address and do the crime count by address out of a map, it becomes extremely useful to identify patterns and then display the same information in a very effective manner in this map. So again, it depends on what you're trying to do with the map. Displaying lines. So moving on to line vector data. For analytical maps, most lines are ground features. Most of the maps we work with as planners or real estate people or whatever our field is, a line is typically a background. So like street features, or could be some kind of administrative boundaries or city boundary, stuff like that. So these features should be light shades, because these are not really extremely critical features. We have more important data on the maps for mostly what we do, so it's usually preferred to use gray or light brown to actually display these features. So for example, contour lines in this map, they're important to identify the terrain, but they're not extremely critical, so you got to use like a light brown to display this information. And the same goes with streets, so you have to use the same information, same color combination to actually display this line. So displaying lines, maybe sometimes we need to consider using dashed lines to signify less important features and solid lines for the more important ones. In this example, streets are more important than some of the internal streets, like so we need to show those line weights or maybe use dashed line and so on and so forth. So there are some pre-existing reference styles that you can use. So anything you want, we can actually search for a symbol and actually find it, so in most cases. So I'll show you how to do that when we do the walkthrough. So displaying polygons, consider using no outline or dark gray for boundaries of most polygons, because dark gray makes polygons prominent enough. So if you use outlines, they actually draw too much attention to themselves when you have a lot more important features on the map. So this kind of a map versus an outlined polygon map would be much preferred, because you can now actually highlight the features that are more important to you. So you see the difference. So yeah, again, these are basic cartographic principles that you need to employ while designing your maps, because a good map is all about paying attention to little things. Displaying polygons, again, we need to consider using texture for black and white copies, especially when you work in the public sector or working for a public sector client. They usually don't have the budgets, or they usually print out their maps in black and white, or their reports in black and white. So when you actually do color copies and they print that stuff out in black and white, it could be extremely confusing for them. Especially when you use warmer colors, they all look the same. So anyway, so you need to use, depending, again, this is about knowing your client and knowing who your audience will be, so that you can come up with the better color schemes. So graphic hierarchy is very critical. Again, assign bright colors to important graphics known as figure, all features in figure. So that's not, so instead you need to identify the features which are ground features and assign drab colors to graphic elements that provide orientation or context, especially shades of gray. So now you know that the points are the actual important ones, not everything. In this, you couldn't say what's important and what's not. Here you can clearly say what is important. So again, identifying your figure versus ground features is going to be critical in designing your map. So graphic hierarchy, place stronger boundary such as heavy black line around polygons that are important to increase the figure, and use coarse or heavy crosshatch or pattern to make some polygons more important by placing them in figure. So different things you can play with and make sure the map is actually conveying your audience your story that you want to say. Graphic hierarchy example here, you can see everything is sort of in like colors all over the place essentially, but you can't really see the figure features so prominently, which looks like the 911 calls, a set of them at least. So once you actually identify the ground features, which are the streets and the buildings, you can tone them down maybe in grays or browns, light browns or something, and then you get a much better looking graphic. So we will take a short break and continue with GIS queries. So GIS queries, you know what a query is. Query is sort of like asking a question. So there is a powerful relationship between the data table and a vector-based graphics, which is very unique to GIS. We know these spatial relationships is what GIS is all about. So records from feature attribute table are selected by using a query criteria, and then a query will automatically highlight the corresponding graphic features. So that's what a GIS query means. So when you ask a question which is sort of like related to your table, and then the query will be highlighted using the graphic features. So we'll see how that works. A simple query criteria is goes something like this: data attribute or field name, logical operator, value. So for example, in the 911 call point data we just saw, the nature of code nature of code, or the type of crime, is equal to drugs. Is a simple query asking the map to spit out the data where the nature code is equal to drugs. So for example, the date after greater than or equal to 2004 July 1st. July 1st. So these are simple queries which are actually written based on the attribute data, and then you get, we'll see what the results will be. So percentage is a wildcard that you can use when you are unsure about a type of the exact values. So what we can do is use percentage standard percentage as a wildcard to actually let the GIS cast a wider net, so to speak. In theory, the percentage symbol stands for 0, 1 or more characters of any kind. So it's sort of like a wildcard in itself. So name like Burr, it could be Burlington or Burton or whatever that is. So anyways, we can use percentage to actually in cases of uncertainty or to cast a wider net. So for example, in this case, nature code like Burr would spit out all the values with starting with the letters BUR, including burglaries, business burglaries, and residential burglaries. So that's why it's it's very useful, because You can see obviously why it's very useful. So simple attribute queries, where you're asking, there's a query builder. We'll look at it within the walkthrough again. So, and how to use those. All these are the logical operators, and these are all the fields or data attribute fields that you have in the table, and then you can actually create a simple query based on those. So in this query, you're asking, this is the entire data set, and you're asking the data to spit out the value where the nature of crime has been related to drugs. So it spits out a subset of data. Compound attribute queries are two or more simple queries with logical connectives and are the two basic connectives that you actually use to actually create like this compound query. For example, nature of crime is drugs, which have been done after or after 2004 August 1st is a compound query because it uses two fields to actually come up with a map. So it selects records that satisfies both the criteria simultaneously. So the result are crimes that are committed after August 1st. So compound attribute queries, you see how this is going to work. Now, if you run the query, you get a much smaller set of data than just running nature code is equal to drugs, because you are adding one more layer to the query by saying I want to select only the crimes that have been crimes that are committed after 2004 August 1st. So layers, groups, scale, thresholds. So you organize your layers within the map, and you name your groups. You create your analysis into one groups, and your base layers or ground features into one group, and so on and so forth. And you name them logically, groups and names logically, because it's once you have like 3 or 4 layers in your map, that's not going to be a big deal. But what if you have 50 layers in your map or 100 layers in your map? That's going to be extremely difficult to keep track of what's on, what's not on, what should be displaying, what should be labeled, so on and so forth. So it's extremely important to organize your data into layer groups. I'll show you how to create groups once we are in the walkthrough, but just remember that groups are extremely important. Minimum scale threshold is nothing but let's talk about this. Like when you are at when you are looking at the entire United States map, the census tract, which is the second smallest census geography we have, is extremely irrelevant in this. So what you need to do is make sure that your tracks don't show up when you are actually at this scale. So that's what a minimum scale threshold does, is make sure that when you are zoomed beyond a particular scale, the features will not be visible. So when you are at a state level or something like that, it's going to turn off these track layers so that they won't be distracting in a way, and because that's not what we want to do. When you're looking at the states, is not look at census tract data. We want to look at state data. So minimum scale threshold, tracks are displayed when zoomed in. So when you actually zoom in to like a county level, or maybe a little, could be even at the state level, you can actually show some of these census tracts. So you need to decide when you're designing your map, what is that minimum scale threshold, whether it's at a state level or like a county level, or whatever that level is to display the features you want. So again, these features will become available at the minimum scale threshold when zoomed in. Beyond that, maximum scale threshold. So what happens when you set this or enable this this functionality on a particular layer is when you actually zoom in, this will not be visible anymore. So the state population will disappear when zoomed into a state, and then the census tracts will start to appear at that level, because at this level, looking at the schematic map or a thematic map for the entire United States population is irrelevant. So again, the maximum scale threshold is also very critical when you design your map documents. We'll see how that's done once we're on the walkthrough, and then let's talk about hyperlinks and map tips. So hyperlinks are like the name itself, links images, documents, or web pages to features on a map. So once you enable this hyperlink, you can actually click on these features and go to that particular link, like an image or like a web page. And provide additional way to find information about your map features, not just identify, not just the data that you have in the attribute table, but actually giving more information than what you actually have. So again, one more way to do that is map tips. Once you actually scroll or point your mouse or a feature, it's gonna pop up some information as map tips, which is going to be useful information, like quick information about a particular piece of data. So in summary, we talked about choropleth maps, colors, vector GIS display. We talked about GIS queries and map layers and scale thresholds, and we also spoke about hyperlinks and map tips. About all, we'll be actually seeing them in action during the walkthrough. Okay, that's the end of first part of this week's presentation, and we will pick it up with the second part pretty soon. Thank you.